Good evening, everyone. Happy Friday. Woo! You have made it to the end. Come on in and breathe it all in, guys. Welcome, 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 welcome. I'm so excited that you are here to join me today. Glad that you guys made it to the end of the week. Guess what? You did it. You made it. Now it is the weekend, so you can relax. All right. So, of course, we're still going through what? Algebra 2, which is part of our algebra series of the math of the unknown. I'm going to cover a few subjects for today. Of course, this is a live tutoring session. So if you have any questions, please comment them below. Also, if you can give me a thumbs up, a heart, or any indication that you can hear me, please go ahead and do so we can get started. Other than that, I hope you're having a funky, fresh, and fabulous Friday. And let's get started and finish strong, guys. Thank you so much for the hearts and the thumbs up. Let's get started. Thank you. All right, beautiful people. We are going into quadratic functions and inequalities. So, first things first, a quadratic equation is described by an equation of the following form. So, you have 8x squared Wait a minute. Okay. What's going on? But we rebuke the disconnection on my screen right now. All right. Where was I? Okay. 8x squared plus bx plus c equals 0. So now, if you notice, a quadratic function is a trinomial. If you notice, we have been doing a lot of factoring, a lot of solving. All that led up to us getting here, which is our main event equation dealing with algebra, which is the quadratic equation. You'll see odd and even functions a lot, but the main function that you work through in Algebra 2 is the quadratic function. You'll see it as an equal equation, or you will see it as an inequality, meaning it's going to be either greater than, equal to, less than, equal to, greater than, or less than. And so quadratic equation, the quadratic term is the first term raised to the second power. The linear term is the first term raised, the second term raised to the first power. And of course, the constant term, that will be C. That term is the last term. And of course, that is what completes our quadratic function and equation. So in order for it to be mostly quadratic, you will see it as a leading term of x squared. So it could be x squared minus 9, x squared plus 7x plus 10, or it could just be x squared plus 7x without the 10. All of those are considered quadratic equations. Why? Because it leads with the term of your variable to the second power. So, of course, when you're graphing your quadratic function, it looks like a U or a horseshoe. And so either both tails will point up or both tails will point down. And the quadratic function is the beginning of all even functions. So know that all even functions, both tails go up or both tails go down. If it's positive, both tails go up. If it's negative, both tails go down. Okay? Any questions about the graph? Now, you can find your Y-intercept because there is a sometimes there is a Y-intercept for your quadratic equation. If it is, normally you could take your function of y or function of f of x. Know that function of f of x and function y, they are the exact same thing because y is a function of x. Because in order to get your y, you must first plug in your x. Therefore, the function of x is y. So now, the intercept is always the constant. So say for instance, you have x squared plus 2x plus 3. To solve, you simply change all of your x's into 0. And once you do that, of course, 0 squared is 0 plus 2 times 0, which is 0, plus 3, that equals 3. So your y-intercept would be 0, 3. Okay? So y-intercepts, simply y equals c. So if c is positive, it's going to be a positive 3. If c is negative, c is going to be a negative 3. Next, we have our axis of symmetry. What that means is, if you remember axis of symmetry, all it is at what point of x, where x equals a number, does my U split in half? Because axis of symmetry is simply taking your graph, splitting it in half, and where it can fold across each other. So how do we find that answer with a quadratic equation? Well, x equals the inverse of b all over 2 times a. This is how you find the axis of symmetry. This is the equation for axis of symmetry. Now, once you find the axis of symmetry, you can also find what we call the max and min value of your graph, or another name for it is your vertex. Your vertex is the center point, the highest and center point, the highest or lowest center point of your quadratic equation. So once you find your axis of symmetry, you then can take that number and plug it back into your equation, your original equation, to find your y, which would allow you to find your vertex, because your vertex is a coordinate point of x comma y. So if your axis is negative b over 2a, then your vertex would be negative b over 2a, and then function of negative b over 2a. So what does that look like? How does this sound? What are the examples for it? Well, here's your example. Say, for instance, we have x squared plus 6x plus 9. And I want my axis of symmetry and my vertex. Well, axis of symmetry says that I take the leading coefficient of b, which would be the second term, and the leading coefficient of a, which would be my first term. So, of course, you know, first term, if it does not have a number in front, it's understood as 1. So, my axis of symmetry is negative b over 2a, or the inverse of b over 2a. So, x equals the inverse of b, which is 6, all over 2 times a, which is 1. And of course, negative 6 is all over 2. And my axis of symmetry is where x equals a negative 3. So if I were to draw a graph, negative 3 would be over here. And of course, my axis of symmetry would be on, well, it would be actually on the 3. And it would be in the middle of our graph. And once I find that, then I can take my negative 3 and put it in my original function, because my axis is x equals negative 3. And so If my axis is -3, then I will put -3 -3 squared plus 6 times -3 plus 9. And of course, -3 squared, that is 9, minus 6 times a -3, that of course will be a minus 18. And of course, that will still be a plus 9 on the end. So then 9 minus 18 plus 9, or 9 plus 9, which is 18, minus 18, that'll give me 0. So my vertex, or my minimum, value, or vertex, because remember, well, haven't told you guys yet, but if it's positive, there's a minimum value. If it's negative, there's a maximum value, because the negatives, both ends point down, positives, both ends point up. So my minimum value, or my vertex, is -3, 0. And of course, if you want your Y-intercept, well, if you remember us plug in 0 here and 0 here, that'll make all of this 0. And of course, 0 plus 9 would make it just 9. So my Y-intercept would be 0, 9. Any questions on axis of symmetry, Y-intercept, or the vertex? Or the maximum, or the max and minimum value, which is the vertex? Now, when dealing with your graph, you will have solutions. And what I mean by real solutions simply mean where the graph touches, for X intercepts. So you have roots. Roots are simply your X intercept and Y-intercept. X-intercept is always a number and 0. Y-intercept is always 0 and a number. Now, the best way you can tell if you are going to have 1, 2, or no solutions is based on, if you're looking at your graph, one solution means your U is sitting on top of the x-axis at one point. That would be considered one solution. And typically that is if you have like a double what they call a double root or double real root, or when you have a perfect square root, like when you have x minus 3 squared, that is considered a one solution, because once you solve for it, the only time there's an x-intercept with this type of equation is when x equals 0, when x equals 3. So your x-intercept would be 3, 0. And your y-intercept, once you foil it out, it'll be x squared minus 6x plus 9. And of course, your y-intercept would be your c, or the last term, which would be 9. So that'll be 0, 9. So whenever your graph is sitting on the x-axis at one point, that means you only have one real x solution. Now, if your graph touches x twice, that means you have two real solutions, which are two x-intercepts. And that usually happens when you say, for instance, you have the x squared plus 7x plus 10. So, of course, that'll be x plus 5 and x plus 2. And, of course, you would set those to equal to, both of those to equal to 0, and x would equal a negative 5, and x would equal a negative 2. So that means you'll have an intercept of negative 2, 0, and a intercept of negative 5, 0. So whenever you are seeing on your graph that you're touching the x-axis twice, you will have two real solutions. Now, if you have a graph and it doesn't touch the x-axis, that means your graph has no real solution. This is where the complex and the I numbers come in, imaginary numbers, meaning your graph will never touch the x-axis. It's like the x-axis has an asymptote against it. So that is for an equation like x squared plus x plus 2. For this type of equation, of course, if you did the quadratic formula and if you tried to factor it, there is no real solution for x squared plus x plus 2, because there's nothing multiplied together give you 2, added together is going to give you 1. Because the only solution to the product of 2 is 2 and 1, and of course 2 plus 1 is 3. Not 1. Therefore, there's no real solution to your graph. So when you graph it, you won't touch the x-axis. It will be off to the side up or down to the side left or down to the side up or up to the side down. Whichever your graph tells you, that's how it's going to look. It's not going to touch the x-axis at all. So that's when you're dealing with the complex numbers and imaginary numbers. And this teaches you how to understand how the quadratic graphs are going to look. So we can solve our equations by different ways. You can solve them by looking at the graph. And of course, the graph can give you your zeros for x, which say for instance you have a graph and your graph touches at 1 and 3 as your x-axis. You could easily say, well, we know that x equals 1 and x equals 3. Therefore, if I subtract 1 on both sides, that'll give me x minus 1. And if I subtract 3 on both sides, that'll give me x minus 3. And based on that, that would be my graphing function. And then once I graph it out, that should be x squared minus 4x plus 3. And of course, the graph would touch, if I extend my graph out correctly, it should touch the y-axis as such. It won't be as wide, but it should give me like a U function going on. So it would touch at 3, 0, 3, and it'll touch at 1, 0, and 3, 0. Which of course proves that you have 2 solutions. So that's how you could solve it based off of graphing. Next, you can solve it by factoring. And you'll see equations like x squared plus 6x, 2x squared plus 7x, and it equals 15. Or x squared plus 16x plus 64 equals 0. So I'm going to expand this right quick. So to solve the first equation, well, if you don't have a third term, that means that more than likely it will not touch the y-axis. So what does that mean if it touches the y-axis? Well, technically it does touch the y-axis. It touches the y-axis where 0 is 0. But this is how this would look. You have x squared plus 6x. Know that x squared plus 6x, you can factor out an x. Meaning once I pull out an x, that means the x squared becomes an x, and the 6x becomes a 6. So then I set both of these up to equal 0. And once I do that, because they're multiplying to each other, I can say x equals 0, which is 0, comma 0. And then x plus 6 equals 0, which will give me, if I subtract 6 on both sides, that'll give me x equals a negative 6, which of course gives me negative 6 and 0. And of course, those are considered my two roots, my two real solutions. And this will also help me graph my equation. So my solution set is negative 6 and 0. You can also put it as 0, negative 6. A solution set doesn't matter. It doesn't matter which way you put it. Just know that that's your solution set for your x's. And of course, the way you can tell if a solution set, plug in your answers, and of course your answers should equal each other. So now what if you have 2x squared plus 7x equals 15? Well, to make it a quadratic solvable problem, you can subtract 15 on both sides, and that'll give you 2x squared plus 7x minus 15 equals 0. Now, if you remember, there are two ways you can solve this problem. Of course, for me, I'm going to divide my first term out to give me 2 and multiply it to my last term. Divide the 2 out to give me x squared plus 7x. And then negative 15, that's times 2. That gives me my negative 30. And I equal that to 0. All right, so once I do that, I can break these down into 2 brackets. And since it's plus minus, that'll be x plus and x minus. Now, what multiplied together gives me 30. What added together what subtracted from each other gives me 7. Well, you have the multiples of 30, which are 1, 30, 2, 15, 3, 10, 5, 6. So, of course, 30 minus 1 is 29. 15 minus 2 is 13. 10 minus 3 is 7. And 6 minus 5 is 1. So, my solution answer would be x plus 10, because since my middle is positive, my bigger number must be positive, and it equal times x plus 10, and we multiply x minus 3, and we equal that to 0. Then, of course, remember I said you could put your 2 back into the equation by dividing the constant by 2, which of course that gives me x plus 5 and x minus 3 over 2 to equal 0. Once I set each one of them to equal 0 because they're multiplying to each other, x plus 5 equals 0. X minus 3 over 2 equals 0. And of course, subtract 5 on both sides gives me an x equals negative 5. Add 3 halves on both sides, and x gives me a 3 over 2. So my solution set are two real solutions, and it is negative 5 and 3 over 2. Next, of course, you have x squared plus 16x plus 64 equals 0. This is considered a double root. Double root simply means you are only going to have one real solution. So now, when I break these two, break this down into two parts, that's going to be x plus and x plus, and it's going to equal to 0. So then what multiplied together gives me 64? What added together gives me 16? Well, of course, that's 8 and 8, because 8 plus 8 is 16. 8 times 8 is 64. So because they are double, I can merge them together to say x, since I have x plus 8 to the first times x plus 8 to the first. That is x plus 8 to the 1 plus 1 based on exponent rules. And that gives me x plus 8 squared equals 0. Then I take the square root of each on both sides, and that gives me x plus 8 equals 0. And of course, subtract 8 on both sides, subtract 8 on both sides. And x equals a negative 8. So that means my solution set is only negative 8. Any questions before we move on? All right, moving on. Say, for instance, you are given the question, write a quadratic equation with 1/2 and negative 5 as its roots. Simply what that means is x equals 1/2 and x equals negative 5. So with the roots, which are the real solutions to your equation, you can find your quadratic equation by doing this two ways. You can either do the quadratic formula with given roots, which is if x equals p and X equals Q, then X minus P times X minus Q equals 0. So based on that solution, I can make 1/2 P and 1/2 Q. (1/2 P and -5Q). So X minus 1/2 and X minus -5. Both of those equal 0. Then, of course, X minus 1/2 times X plus 5, that equals 0. Once I do that, I can FOIL. And of course, FOIL allows me to go X squared plus 5X minus 1/2 X minus 5/2 equals 0. And of course, 5X minus 1/2 X, which of course would be 10/2, because if I change my whole number into the fraction form over 2, 10/2 still gives me 5. So 10/2 minus 1/2, bring down my X squared, that'll give me 9/2X minus 5/2 equals 0. And once I do that, then of course, when you have fractions as part of your quadratic formula, you want to remove those fractions out. And seeing as how both of our fractions are being divided by 2, you can multiply everything by 2 to get rid of your fractions, which gives me 2x squared plus 9x minus 5 equals 0 for my solution. Now, this whole thing can be done a whole nother way. This was just the equation way. Now, if I still do X equals 1/2 and X equals a -5, I can subtract 1/2 on both sides. Well, before I even subtract 1/2 on both sides, I would add 5 on both sides here, and that'll give me my X plus 5. Also, if you notice, X equals 1/2, you can do a proportion, which would put the x over 1 and cross multiply, or to change the fraction into a whole number, I will multiply everything by 2. So then 2x equals 1, because the 2's cancel when I multiply 2 times 1/2. Then I could subtract 1 on both sides, and that gives me 2x minus 1. And of course, 2x minus 1 and x plus 5. That equals 0. And of course, I do that. FOIL method, 2x squared plus 10x minus x or 1x, whichever you prefer, minus 5. That equals 0. And then once I combine like terms, 2x squared plus 9x minus 5, that equals 0. Not bad, huh? So you have 2 distinctive ways that you can do this problem. I personally prefer this one over this one, only because this one is shorter. But if you want to use the formula in order to make sure that you're doing everything step by step, I also recommend that one as well. Any questions on writing an equation with given roots? All right. So now, how do you complete the square for solving for your square? So now, say for instance, you have an equation with rational roots. If x squared is equal to n, then x can be equal to plus or minus the square root of n. Now, an example of that would be if it's rational, x squared plus 10x plus 25 equals 49. Now, x plus 10x plus 25 is a perfect square. And what I mean is that I can, or a double root, perfect square, double root, they are exactly the same, meaning what multiply together gives me 25, what added together gives me 10. Of course, that is 5. So no, x plus 5 is going to be multiplied to itself twice. I can say x plus 5 is raised to the second power and it equals 49. Once I have done that, then I take the square root on both sides. Now, when you have the square root on both sides with rational or irrational, you will get two answers because you're getting two roots. So you have, well, technically you're not getting, you're getting based off of real roots and irrational roots. Which of course are based on the x-axis. So, continuing on, you have x plus 5 equals, when you're solving for an equation like this, it will always be plus or minus 7 because the square root of 49, because negative 7 times negative 7 can give me a positive 49. And of course, positive 7 times positive 7 gives me a positive 49. So the reason why I did a plus or minus, because with quadratic equations, when it comes to their roots, there's either 2 roots, 1 root, or no root. So when you have the same square or a perfect square, whether it's with rational or irrational numbers, you will have a double root or a 2-solution root. So I can subtract 5 on both sides, and that will give me x equals negative 5 plus or minus 7, which gives two answers of x equals negative 5 plus 7 and x equals negative 5 minus 7, which will contain a solution set of negative 5 plus 7. That gives me 2, because 7 minus 5 is 2. And then negative 5 minus 7, well, like signs, you add them together. That gives me a negative 12. So my solution set is 2, negative 12. Those are my roots. Those are my solution sets. This is where x touches, this is where the graph touches the x-axis or the x-intercepts. Now, where there are rational roots, there are also irrational roots. So if you have an irrational root solution, this is how you would write it. So say for instance, I have x squared minus 6x plus 9 equals 32. Well, perfect solution. What multiplied together gives me 9. What added together gives me a negative 6. Well, that would be a negative 3. And of course, since it'll be x minus 3 times x minus 3, this could be raised to the second power, and it equals 32. So then I take the square root of 32 on both sides. And of course, x minus 3 equals square root of 32. Now, of course, the square root of 32 has a perfect root in it. And the perfect root inside of 32 is 16. And of course, 16 times 2, that gives me 32. Therefore, I can split those two apart, and that'll give me a plus or minus 4 square roots of 2. The 4 came from the square root of 16, and the 2 stayed inside because it's not rational. Therefore, you must leave it as a square root. Once I find that answer, then I can say, well, add 3 on both sides of the equal sign, and my x equals 3 plus or minus 4 square roots of 2. And of course, two solution set, that would be x equals 3 plus 4 square root of 2, or x equals 3 minus 4 square root of 2. Now, the teacher may ask you to give the solution, the approximate solution, meaning go ahead and calculate your answer in a calculator. Me personally, I would make sure that we stop here, because those are your solution sets, and really there's nothing else you can do further besides grab a calculator and give the calculated solution. So if I had a calculator, x rounded to the first decimal place or the 10th place would be approximately 8.7 and negative 2.7. And of course, you use the approximation equal sign, which looks like double tildes on top of each other in order to find the solution. But it all depends on what the teacher asks for. If it says round to the nearest decimal place or first decimal place, this will be your solution. If it just says solve the equation using the square root property for rational roots or irrational roots, this will be your answer. Any questions before we move on to learning how to complete a square? All right, moving on. Solving the equation by completing the square. You will see it written in so many ways, but it will either be where you do not have a constant like x squared plus 12x plus c, and you have to find c, or you may have x squared plus 2x minus 3. And of course, you can take that and complete the square as well. So now you complete the square. How you find the completion of your square or your constant to complete the square. For the first equation, I would take the second term divided by 2. Once I divide it by 2, I square it. and that gives me my constant. So your equation on how to find the constant is the second term divided by 2, and you square it. That is how you find the constant, or the third term. So then my answer becomes x squared plus 12x plus 36. And of course, that equals 0. And with it being completing a square, that would make it x squared well, not x squared, sorry about that, x plus 6 squared, that equals 0. And the reason I wrote it like that is because what multiplied together gives me 36, but added together gives me 12. Well, we both know that that is 6. Therefore, completing my square means I can write my answer as that to equal 0, or completing the square, I can just write x plus 6 raised to the second power. Now, for an equation like the second one to our right, to complete the square and you have a constant, but the constant won't give you a complete square, you must first remove the constant. Well, you must first set it to equal to 0. Remove the existing constant by adding its opposite or subtracting its opposite. And that'll give you x squared plus 2x equals 3. Now, of course, you still find the constant by dividing the second term by 2 and squaring it. So 2 divided by 2, that's 1. And of course, 1 squared is 1. Therefore, my perfect square is x squared plus 2x plus 1. Now, what you do on the left side, you must also do on the right side, which gives you your pluses to complete your square. So then x squared plus 2x plus 1, that becomes x plus 1 squared, because 1 times 1 is 1, 1 plus 1 is 2, and 3 plus 1, that gives me 4. Now, you can solve an equation by completing a square. You can do this when your leading coefficient is 1. You can do this when your leading coefficient is not 1. What does it look like when your leading coefficient is 1? Well, like we did earlier, where we added the 1 on both sides and you solve for 4, all that good stuff. Well, to take it a step further, x squared of course, once we solve for that, we divide both sides by 4. That gives, we take the square root on both sides, which of course square root of x plus 1 squared, that is x plus 1. And of course square root of 4 is plus or minus 2. Subtract 1 on both sides, and x equals -1 plus or minus 2. And of course, that will give me x equals -1 plus 2, x equals -1 minus 2, x would equal 1, and x will equal a -3. Solution 1, comma, -3. Now, another example would be, say for instance, you have x squared plus 8x minus 20 equals 0. Of course, we're completing the square. I will add my 20 on both sides. And that'll give me x squared plus 8x. And that will equal 20. Of course, you know, to complete the square, divide the second term by 2, then square it. 8 divided by 2 is 4. Square it. And that'll give me 16. So once I find that, then x squared plus 8x, I will add 16 to my left, and I will add 16 to the 20 to my right. And of course, once I condense or factor my x squared plus 8x plus 16, of course, that is x plus 4 squared, and that equals 20 plus 16, that's 36. Now, take the square root on both sides. X plus 4 equals plus or minus 6. Subtract 4 on both sides. And x equals -4 plus or minus 6, which is x equals -4 plus 6. And that gives me a +2, or x equals -4 minus 6, and that gives me a -10. And my solution set, 2 and -10. Now, what if my equation does not equal 1? How do I complete the square if it does not equal 1? Say, for instance, I have 2, that's a really big 2. 2x squared minus 5x plus 3 equals 0. Now, to make sure everyone is on the same playing field, I can divide everything by 2. That way I have the correct solution set and I can complete my square. Now, when you get ready to complete your square for solving, there will be fractions. Don't worry, fractions are supposed to happen with this. Fractions are okay when you're solving your equation while completing a square. So if I divide everything by 2 based on my leading coefficient, because when it's not 1, you can divide everything by that leading coefficient. And leading coefficient, of course, is always the first term, which is raised to the second power of the quadratic equation. So now, divide everything by 2, I get x squared minus 5 over 2x plus 3 over 2. Now you can do this another way by simply subtracting 3 on both sides, and then once I subtract 3 on both sides, complete the square, and you multiply the 2 through everything, which honestly, I feel like is a very long process. So to cut out the extra steps and the middleman, I'm going to give you a quick cheat sheet. How about that? So now, subtract 3 halves on both sides, and that will give me x squared minus 5 over 2x, and that will equal negative 3 halves. Then I divide my negative 5 over 2 by 2, or multiply it by 1/2. Because whenever you're dividing a fraction by a whole number, you can flip the sign and flip the whole number into its fractional form, which would be negative 5 over 2 times 1/2. And then you square it. Once I do that, then negative 5 times 1 is negative 5. Negative, and of course 2 times 2, that gives me 4. And when I square it, that gives me a positive, because squaring makes your answer positive. And that gives me a positive 25 over 16. So I'm going to add 25 over 16 on one side, and I'm going to add 25 over 16 on the other side. And once I break that down, what multiply together gives me 25 over 16. What subtracted but added together to give me a negative 5 over 2. That, of course, is going to be 5 over 4. If you notice, your completion, if you pay attention, your completion is always what you break down your binomial square into. So if your completing square on the inside of the parentheses before you square it is a positive 6, more than likely it's going to be plus 6. So since it's a negative 5 over 4, it's still going to be 5 over 4 squared. And then negative 3/2 plus 25 over 16, that gives me a positive 1 over 16. Then, of course, you take the square root on both sides, square root on both sides. And I get x minus 5 over 4 equals plus or minus 1/4. Because remember, when you take the square root of a fraction, you can take the square root of each number. So I add 5 over 4 on both sides. And that leads me to X equals 5/4 plus or minus 1/4. So X equals 5/4 plus 1/4. X equals 5/4 minus 1/4, which once I give my solved solution set, 5/4 plus 1/4, that is going to give me 6/4 or 3/2. And 5/4 minus 1/4, that gives me 4/4 or 1. So my solution set is 1, 3/2. Now, how do you solve this equation? By completing the square if you have a complex solution, meaning imaginary numbers. If you remember yesterday, we covered imaginary numbers. So because we covered imaginary numbers, we can solve our quadratic equations to find our imaginary numbers. So let's say you have x squared and you add it to 4x and you add it to 11 and that equals 0. Well, first, of course, subtract 11 on both sides. That gives me my x squared plus 4x and that equals a negative 11. Of course, we take our 4 divided by 2, square it. 4 divided by 2 is 2, square it. And 2 squared, of course, is still what? 4. So now, add 4 on one side, add 4 on the other side. Once I do that, that breaks this down into what times 4 gives, what times itself gives me 4, what added to itself gives me 4, and of course that would be a plus 2, and it's squared, and that equals a negative 7. Take the square root, take the square root, and of course, x plus 2 equals I square root of 7. Remember, the negative can be pulled out of the square root by simply changing the outside to an I, because the square root of negative 1 equals I. Therefore, once I take the square root of a negative 1, that equals I. I can pull the negative sign on the outside. And then, of course, it's not a perfect root. Therefore, it's irrational and it must stay on the inside. So when I did that, notice that it's going to be plus or minus I square root of 7, because we still are going to have two different solutions. Subtract 2 on both sides. And my final answer, because you can't do anything else to imaginary numbers, is going to be x equals negative 2 plus or minus I square root of 7. And that can be wrote as just that, or you can do I, or you can do x plus I square root of 7, or and x equals negative 2 minus I square root of 7. Either of these can be written as your answer. So next up, we have a recap of the quadratic formula and a discriminant. So, how did the quadratic formula come about? Well, somebody got fancy and said you can take the standard form of the quadratic equation, and they developed the quadratic formula. So, if anyone, this will be someone's homework if you're watching, if anyone can comment below who was the person that came up with the quadratic formula based off of completing the square root, you may be able to get a prize. I don't know what the prize will be yet, but if you're the first one to let me know who came up with the quadratic formula, I'll make sure and guarantee that I get you your prize as soon as possible. And this contest will go, I say, give it 2 weeks. And if you are the first 3 people that get it and can prove where you got your answer from, you will get a prize. Okay? So this is how they came up with quadratic formula. Of course, they did it based off completing a square. So in order for me to complete this square, I must first divide everything by the leading coefficient, which of course would be A. Once I do that, of course, that becomes x squared plus b over a x plus c over a, that equals 0. Then, of course, you subtract CA on both sides to get rid of it. That gives me x squared plus b over ax, and that equals a negative c over a. And of course, to find the completing of the square, I must first take BA, which is a fraction. And remember, since I'm dividing by 2, dividing a fraction by a whole number flips it into a fraction, and then you can square it. So now once I do that, then that gives me b over 2a squared, which of course that gives me b squared over 4a squared, because you're squaring the 2 and you're squaring the a and you're squaring the b, you're squaring everything. So then I add b squared 4a squared on both sides which when I break this down, if you remember what I said about the inside being your perfect square completion, that'll give me x plus b over 2a. Square that. And of course, in order to get my bottoms of my fractions of the c over a and the b squared over 4a squared to match, I must multiply the c over a by 4a to top and bottom. Once I do that, that'll give me negative 4ac, and all of that is over 4a squared. So negative 4ac over 4 squared, that gives me my b squared minus 4 times a times c, all over 4a squared. Once it did that, then of course, take the square root on both sides. And of course, when you take the square root of the top of the fraction, you take the square root on top and bottom, which gives me x plus b over 2a equals the square root of b squared minus 4 times a times c, and all of that is over 2a, and I subtract b over 2a on both sides, and that leaves me with my final answer of the quadratic formula, which is the inverse of b plus or minus, because of course you know the square root of anything is the plus or minus, b squared minus 4a, 4 times a times c, and all of that is over 2a. And that is how the quadratic formula was born. So, of course, with the quadratic formula, you will have either one rational root, which means you'll have two answers. Well, two rational roots, which means you'll have two answers. One rational root, which means you'll have one answer. Two irrational roots, which, if you do get those, you won't have to put them in you don't have to put them in decimal form. You can leave them as x equals the inverse of b plus the square root of b squared minus 4ac all over 2a, or and the inverse of b minus the square root of b squared minus 4ac, and all of that would be over 2a. So you take the leading coefficients of these answers, and once you take the leading coefficients of these answers, you can solve with the quadratic formula. The only one that'll probably be left with your second term plus the square root of the square root of b squared minus 4ac, whatever that answer is, if that's irrational, like if it's 14, it's going to remain a square root of 14. And of course, if a is 1 or if a is 2, it's either going to be the square root of 4, all over 4, all over 1, well, all over 2, or any measurements of 2. So it'll be all over 2, all over 4, all over 8. And if they're all even numbers, you can divide the 2 out, which will bring you right back to all over 2. So say, for instance, you have your b was 1, so that made that -1, plus or minus b squared minus 4ac. And instance 2, the a was 1, so therefore that was 2. So that means your answers would be x equals -1 plus the square root of 14 over 2, and -1 minus the square root of 14. And all of that would be over 2. And so that's what I mean when I say irrational roots. That's how it can be solved. And of course, complex roots, that'll be 2 plus 3 plus or minus 3i, or 2 plus i, 2 plus or minus I square root of 5. Those will be your solutions for the complex roots. And you can leave them together or you can pull them apart, but it's still going to be the same answer. Now, you can determine your root based on your discriminant. The discriminant is simply b squared minus 4 times a times c. That is the value of your discriminant. So now, this can help you determine if your function is 1 root, 1 real root, 2 real roots, or 2 complex roots. Now, if your b squared minus 4 times a times z times c is greater than 0, it is 2 real roots. Now, when you take the square root of b squared minus 4ac, either you are going to have 2 rational roots or 2 irrational roots. And with those root, based on the square root of the discriminant, it'll determine whether you're going to have 2 rational roots or 2 irrational roots. Of course, if you get 2 rational roots, that means you had a perfect square, like the square root of 36, the square root of 25, the square root of 9, the square root of 169. Those are considered 2 rational real roots. Now, say, for instance, you have the square root of 7, the square root of 14, square root of 48. Any of those numbers that are between the perfect square roots, those are considered irrational square roots, and they will remain under the radical sign. And that's only if your discriminant is greater than 0. It will be 2 real roots. So that means X will equal 2 and X will equal 1, or X will equal 5 and X will equal 7, or X will equal -1 plus or minus the square root of 7. Those are your real roots. Now, if your discriminant is equal to 0, you only have one real root. Means X was only going to equal one number. That falls under the category of the double roots, the ones that look like X plus 2 squared or X minus 3 squared. And it will be rational, meaning have an even square root. And it will only touch at the x's, have one X intercept and one real root. So whenever you have the X plus 2 squared, the X minus 3 squared, or if your answer is in this form of X squared plus 6X plus 9, that is considered a double root or a perfect square root, which will give me an X 3 squared. Now, if I didn't know that, then what I could do is take the leading coefficient of the second term, the first term, and the last term, and put it inside of this equation. And of course, that would be 6 squared minus 4 times 1 times 9. And of course, 6 squared, that gives me 36. -4 times 1 is a -4. -4 times 9, that's a -36. And of course, 36 will equal 0. So if that equals 0, that means you only have one solution where X equals a -3. And of course, if your discriminant is less than 0, that means you have two complex solutions, which will be either 2 plus 3i or 2 -2 plus or minus I square root of 19, or -1 plus or minus I square root of 21, and all of that is over 2. Those would be considered complex roots, meaning you don't have any X intercepts. It never touches the x-axis. The discriminant can help you determine whether or not that is a function. Any questions on this? Well, guys, that is all I really had for today. Of course, you know I love and enjoy that you guys tune in with me every week. And so I am announcing that I will continue our tutoring sessions on Saturdays. Saturdays will be our live tutoring sessions, so that way I have open time for those who want one-on-one tutoring sessions. Of course, that will be available once starts, and I will begin Saturday only tutoring on August 22nd. So if you want to continue the live tutoring sessions with me online through Facebook or YouTube, you can do those for free. On Saturday, starting on the 22nd, I will make sure that I have my Saturday schedules posted out early so you'll know exactly when to tune in and when to come and ask questions. A lot of you guys will be starting school back at the end of August. For those who are in Alabama, I know some of you start back on the 28th of August. Some of you will start back in September. The days when school used to start back in September used to be so much fun. You literally had all of your summer and you didn't start school until after Labor Day weekend. I would love for us to get back to those days. But until then, if you have any questions, any concerns, of course, you can reach me at 205-542-5062. 205-542-5062 for texting. If you want to message me on my Facebook, which is of Krishan Mechanico, Mathematics for You Tutorial Services on the Facebook and YouTube pages, you can inbox me, IM, or DM me in all of those platforms. So, other than that, I will see you guys tomorrow. Actually, I'm going to see you guys tomorrow early. I might start it I was going to start it at 12, but hey, I would rather start you off early so that way you can go ahead and spend the rest of your day doing whatever else you want to do. And of course, if you missed the live, no worries. Once the video ends, you can click on any of the lives. They're saved to all Facebook pages and it's saved to the YouTube page. Click on the YouTube link, click on the Facebook page, scroll, click for the videos, and they should be there. Other than that, I hope you guys had a fantastic Friday. You have made to the weekend. And we are going to finish off our Algebra 2 tomorrow. Then after that, we are going to kick in gear for our pre-calculus with trig. And of course, we use that because guess what? The expansion of Algebra 1, Algebra 2 takes us into pre-calculus. And if you are a math person like myself and you love math like I do, or you just want the better understanding of math and you want the advanced learning of math, you will see me tomorrow at 8 a.m. I will be from 8 until about 11, maybe 12. But I definitely will be online for all your tutoring needs. You can reach me at all of my platforms and my phone number because, of course, you know, Miss Chris loves to help all of my people. So, with that being said, I am going to go ahead and end our live now. If you have any questions, inbox, DM, IM, text at 205-542-5060, and I will answer you to my earliest convenience. Other than that, have a fantastic Friday. Enjoy yourselves. Relax, rewind, and definitely release and enjoy yourselves. Have a blessed Friday. I will see you guys tomorrow. Again, this is Miss Chris of Mathematics for You Tutorial Services, LLC, where we are Changing mindsets, one problem at a time. Good night and much love.